We are recording. Okay. So we've got numerical. We're going to talk today about numerical and algebraic expressions, and then we're going to use them as a way to practice evaluating expressions. Okay. And I'll explain it all as we move along, as we go along. So a numeric expression, numeric, or numerical expression. An example of a numerical expression would be 6 plus 2 minus 4 plus 3 minus 7. Right? Or a simpler one would be 4 minus 2 plus 6. All right? Those are all numerical expressions. Why would you call them numerical expressions? Anybody have an idea? Jan?
Because an expression is like kind of a problem,
Mm-hmm.
and numerical is like numbers.
Yes. And how is an expression different than an equation? Lucas?
An equation has an equal sign, an expression doesn't.
Yeah, exactly. So there's no way to solve an expression. You can simplify an expression, right? Does that make sense? But you can't solve it. You can't say, oh, yes, whatever. I mean, you can simplify that and figure out, well, what is 4 minus 2? Well, that's 2, plus 6, that's 8. So we just solved that, right? Or, now, we didn't solve it, we simplified it. This could be simplified as just 8, right? But I'm not solving it, right? Okay? Yes?
Or like you can, or sometimes you can turn expressions into equations, because like 4 minus 2 plus 6.
Right.
You can kind of say in your mind, you can say, well, 4 minus 2 equals 2, so you can simplify to 2 plus 6, and then you can add an equal sign to turn
Right. If you do that, then suddenly it's no longer an expression, it's an equation, right? Right? But a lot of times when you see an expression, the instructions will say simplify. It will not say solve. Okay? Simplify. It's just simplifying whatever you got there. This, you'd have to deal with what's inside the parentheses first. We're going to talk about that tomorrow. Order of operation comes tomorrow. Okay? Now, an algebraic expression, though, you know, this is really quite simple, to be honest with you. That's an algebraic expression. 2x minus 7 is an algebraic expression. X squared plus 2x plus 1 is an algebraic expression. 4x to the 8th y squared minus 2x squared y to the 7th is an algebraic expression. What makes that an algebraic expression? What makes it different from a numerical expression, Mushi? Oh yeah, go ahead.
Yeah.
That is wrong, buddy. That is wrong. You got the wrong answer. Okay, James.
They use letters to represent numbers.
There you go. That is true. What are those letters called?
Variables.
Variables. They call them variables. We use letters of the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, all of them, right? With a few exceptions. Any examples of exceptions of letters that are not a good letter to use? Yeah, Luke.
Z, because it may be mistaken for a 2.
Yeah, you will see a lot of Z's. And so, but you're right. Like a lot of times, you know, a Z, if you write it fast, looks like a 2. And so when I write a Z, I put a little line in the middle. Does that make sense? So that way you can just, you know, oh, that's clearly not a 2, that's a Z. What else? So like if I had 4Z, that looks like 42, right? I don't want to do that unless I put a line in front of through the middle of the Z. Brisa.
T, because it might look at the plus sign.
Right. Sometimes your T's running out of space here. I'll just over here. So like if you say 2T, that looks like 2 plus, right? So when you write a T, you will often see a T in algebra because a lot of times you use a letter that stands for a word like time, right? If you're solving for time in a real example, in a real, in a word problem or something, you might want to make the unknown be a T. So when you make a T, you do like this, 2T, and it's a lowercase, but it has a little hook on the end. Yes, yeah.
L?
L. Oh, yeah. Like, how about 5L? Right? Oh, that's great. Right? You have no idea that's an L. You know,
Make it capital.
you could make it a capital L, right?
Same with
All right.
T. You can
All right,
make capital
and you
T.
could make a capital T for time for T as well. Yes, basic.
Can I use the restroom? And then also I was gonna say 0.
Zero's okay.
Or
Oh, 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 oh. Oh yeah. Oh yeah. 3-0.
3-0.
3-0 plus 5-0 is equal to 8-0.
I mean, it's kind of.
Right? So you don't want to use O's clearly, right? The ones that I tend to use the most are X's and Y's.
That's.
You know, and Z's and A's and B's. And every now and then M's and N's. But you won't see a lot other ones for me.
You could like put a dot in the middle of the zeros so that it would distinguish between a 0 and a 0.
Yeah, you could. It just wouldn't be the best idea. Do you know what I'm saying? Like if I'm doing a word problem and it's talking about, you know, John has 4 oranges and 5 apples. I might use A for apples, 5 apples, but for 4 oranges, I'm not going to put 4O. I might put 4X plus 5A. See what I'm saying? And I might say, oh, orange X equals number of oranges or something, right? So you just have to be aware. So numerical expression versus algebraic expression. The only difference is there are variables in algebraic expression. It's pretty straightforward. So how you use them, or one way in which you will use them this year, is when you get problems that say evaluate. Evaluate. What does evaluate mean? What does evaluate mean? Who knows? Jan, what do you think?
I'm thinking, I guess, does it kind of mean like simplify, but like,
Yeah.
like under like study it, or
Yeah. Well, what is the one of the root words in evaluate?
value?
Value, right? So evaluate means find the value, simplify, and get the value of an expression, okay? Find the actual value. Now, an expression, though, I'm going to be using algebraic expressions. They're going to be really easy at first because we haven't done order of operations. We're going to talk about that tomorrow. And so I don't want to throw hard stuff at you and all that stuff until we've actually done that. But the main thing is just understanding these kind of problems because you'll see them forever. You'll see them for the next 10 years, right? So you could say like evaluate. So here's our first problem. Evaluate the expressions below when x equals -3, y equals 4, and z equals -2. Okay? So here's the first expression. X plus y. So what do? It's really simple, right, Rosemary?
It would be 1.
Well, tell me what I do. I don't care about the answer. Do you understand? The answer is the least important thing in math. I mean, it is important when you're flying to the moon. The most important thing is the process. I want to see the process. Keep going, Rosemary.
So first you look up and you say, well, if he said that x equals -3,
Yeah.
so that means it's -3 plus y. So what's y? Y equals 4.
So-
So your problem is -3 plus 4 now.
Okay, good. Right? Does everybody understand that? We check. Okay, x instead of x, like James had said, x is a real number. It's just that we don't know what it is. But we do now. We know what it is, right? Because they told us, to evaluate this when x equaled -3. Oh, well, that's -3. And when y equals 4. Oh, well, that's y equals 4. So -3 plus 4, let's see, negative times a positive is a negative, right? Is that what I do here?
No, because that's multiplication.
That's multiplication. This is adding and subtracting, right? Positive 1, right? A lot of times what I'll do with these, this is an easy one, but sometimes I'll say, Well, the bigger number is positive. It's 4 minus 3. 4 minus 3. I just, in my brain, I do it in that order, right? As opposed to negative 3 plus 4. I do 4 minus 3. And it's easier to come up with the answer. Okay. All right. What if it was, if b was x minus y? No, let's do x minus z. X minus z. Okay. How about somebody new? Somebody different. Somebody. Okay, Luke.
So you would say x is negative 3 and put it below the x, and you would say z is negative 2,
Okay.
and then you do negative 3 minus negative 2.
So this minus sign does not count for this minus sign. You guys see that? See the difference? The problem, the expression has the minus sign in it. Now z is negative 2. So I've got negative 3 minus 2. So what can I immediately do? John?
You could turn it into the minus on the negative side, turn it to an addition sign.
Right.
and it's
Negative, is that what you're going to say, Jaden? The negative becomes positive, right? So immediately turn that into a plus sign. So what's the final answer? Sienna?
Negative 1.
-1, exactly. -1. All right, what if I gave you this? What if I gave you x, y, z? X, y, z. Okay, Gardner.
Negative 3.
-3.
Times negative 2.
And I'm going to put it in parentheses now, right? Because when I have negatives, when I'm multiplying negatives times negatives and stuff, it's helpful sometimes to use parentheses. Okay, -3 times what?
4 times negative 2.
Times -2. You see why the parentheses are useful there? Okay, great. So what's the answer, Gardner?
The answer is positive 24.
Positive 24.
Yep.
Very good. Excellent. All right, but what if I gave you this? What if I gave you negative xy over z? Negative xy over z. Looking for different hands. Somebody else who hasn't talked. Like, be brave.
You guys all talk.
All right. So basic.
Oh, so first you would want to find the value of the top part, like what x and y times multiplied by each other equals, and then make that negative.
Right. So I have this negative sign right here, right? I've got a negative. And then what is my x? -3. Okay. And then what's my y?
4.
4 times 4.
12.
All over z, which is -2. All right. So
Negative 6. Negative 5.
say it again.
Negative 6.
Okay. So negative times negative is positive. So it's positive 3 times 4. You see that? So that's 12 over -2. Now I have positive divided by negative is negative. 12 divided by 2 is 6. -6. Exactly.
Wow.
You're right.
Wow.
I wanted to get us there, right? Right? Does that make sense? Does everybody understand what I'm doing?
I want to write that down really quick.
That I threw that negative in there. You probably won't see that in the homework tonight, but homework's easy
That's just
because
a
I
good
know we don't have
example.
much time. So I'm just gonna have you practice a little bit. Yes. Yes. That negative, there's a negative there, though. That negative is independent of the negatives up here. You guys all understand that? That you have to write them both. You can't just think, oh, well, this one takes care of the -3, the negative in front of the 3. It doesn't, right? Okay, that's good. So that's basically it. Let's try one harder. I don't think I have any hard ones on there, but let's try a harder one. Let's say I did x squared y squared z squared over x. Okay? So what would I do there? What is square? How many people know what exponents are? Raise your hand if you've been exposed to exponents. I just want to be sure. All right, everybody knows what they are.
Yep.
Right. So what is x squared? Without looking at the, without evaluating, just what is an x squared? What does it mean to say x squared? So Lucas.
X squared is x times x.
X times x. How is that different than 2x?
Oh.
Okay, Irene.
That's x times 2.
Yeah, so x squared is x times x. 2x is x plus x. Do you see the difference?
Yeah.
Right? So when you see a number, does anybody know what that number is called in front of a variable? What is it? You guys remember? What's that number?
Isn't it like a term?
Well, this whole thing is a term. That is a term. That's right. But what is that first number in front of the variable? Does anybody know, Luke? Yeah.
2.
You're right! Oh my gosh! Okay, no, that's right. But that's not what I meant. Jan. It's called a coefficient.
I knew it.
Have you heard that word? So this too is called a coefficient. Okay? You're going to hear me use that word a lot because you got to know it. Right? So the number in front of the variable is the coefficient. Okay? And whenever you see a coefficient in front of a variable, it just tells you how many of them you have. So if I said 4x squared, it just tells me I have 4x squareds. You see what I'm saying? I have x squared plus x squared plus x squared plus x squared. That's what that means. I have 4 of them. I have 4x squared.
Yeah.
Right? You got it? Okay. So now where are we? Evaluate this. Let's evaluate this now. So hands. Let me see. Risa. She had 2 hands up. Did you see that? It was so impressive. I had to call on her. Go ahead. You don't want to do it? Okay. All right. Who wants to do it? Who wants to do it? Jan.
So, you would first insert the numbers that you know. So
Okay.
for x squared, it'd be -3 squared in parentheses.
Parentheses. Are the parentheses important?
Yeah.
Are you sure?
Yeah.
Why?
Because then it's distinguishing the number.
Okay, so everybody watch this for a second. -3 squared. -3 squared.
No, you have
Are
to
they
put-
the same thing?
No,
Yeah, because it means.
No, they're not the same thing.
But it means whatever's in the parentheses squared.
Yes. But what is
Put the exponent.
what is the answer to this? What is -3 squared?
That would be -9.
The exponent only affects what it's next to. It's not next to the negative, it's next to the 3.
Oh.
You follow me? So the negative stays, and then it's 3 squared, which is 9. That is -9. You see that?
Yeah.
Now what about this one though? Now it's saying the square is next to a parenthesis.
Parentheses
That means
missing.
it affects everything inside the parenthesis. Meaning it's now -3 times -3, which is what?
9.
Positive 9. Do you see the difference?
Yeah.
You see the difference? That's why when you're writing these, you gotta use those parentheses. You got to. Right? Okay, so keep going. So, John, I'm sorry, you were working on
Yeah, and then you do 4 squared.
4 squared,
16, and then you do -2 squared.
-2 squared,
And then you can put it over -3.
over -3. Okay. So now we got to simplify this, right? We got to simplify this. So let's simplify. What is -3 in parentheses squared? 9. Okay, so suddenly that's a 9 times 16 times 4 all over -3. Great. And that's a big, yeah, okay. So can I simplify this before I actually start multiplying?
Yeah.
Yeah.
Rosemary.
You can do 9
See, notice the 3. I'm looking to see if the 3 goes into any of these numbers, right? And they do. It goes into the 9. So I could say, I think I just assume, well, let's say negative 3 goes into negative 3 once. Negative 3 goes into 9 negative 3 times. You see that? Positive divided by negative is negative, negative 3, right? So I now have nothing downstairs, right? I just have a 1. So that's fine. So now I just can multiply 3 times 16 times 4. Anybody know what that is?
Negative 192.
Is it right? Is that right? Okay, well, I'll trust you. Negative 192. Because I don't know. 12 times 16? Sounds about right. About there somewhere. So good. Does everybody understand this in general? It makes sense, right? Evaluating these things? Okay. So I'm going to end the lecture, I think. Does anybody have any questions before I end it?
No.
Okay, cool. And